Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be looking at Gluster file systems again. This one took a while to do, and I'll explain that in the video. There were some difficulties in getting this one up, and I certainly missed my deadline of last week. And this is the reason why, but that's what happens when you do upgrades sometimes, when things are really radical changes that are made to the software. So we'll talk about those right after this. Okay, so we're going to compare GlusterFS 8 versus GlusterFS 9. I suppose probably the first place we better start is for those of you that are walking into my channel for the first time and going, GlusterFS, what is that? So let's talk about what it is first. So GlusterFS is what I would call it a next-gen. They don't. I call it a next-gen scalable file system. So basically what it does is it takes disk storage on a particular server and allows you to aggregate those from multiple servers. So you can have, you have to of course have the same size. At least it's recommended that you do. I have never actually tried it with lopsided file systems. I just don't think that's a really good idea, simply because you could potentially run out of disk storage on one server before the others, and that's never a good condition usually. So, but anyway, it aggregates from multiple servers into a single global namespace. Being a file system, it would be the namespace. So as far as the other servers that are accessing, it all looks like one server, even though the files are scattered across the network. So they do recommend that you configure it in threes. And if you want to look at some videos that I've done in the past on how to actually install Gluster from ground zero, I'll put a card up in the corner here so that if you want to see those, you can do that. So, but the idea behind Gluster is it scales up to multiple petabytes, several, about 2, I think, is usually what people talk about, 2 petabytes, maybe 3. But yeah, that's typically where you run into. So you can start small. I have some behind me here that are, a couple of terabytes. And then I have some that scale up to around 28, 30 terabytes right now. I don't have anything bigger than that, but I'm running on ARM, so I probably won't be able to reach a petabyte on ARM servers unless I have a whole bunch of them to do that. So, but it handles thousands of clients. So if you're into workloads where you're trying to share files between a lot of different users, then Gluster is probably a good choice. There is another file server that you can use as well in this market, and that is called Ceph. Ceph is an object store. It does do block storage, and it also does file system storage, but its primary storage is object store. So Gluster is different. Gluster's primary is file store. So it uses native file systems from Linux. That like XFS, ext3, ext4, or ZFS, and then it uses that to form the brick, and then the brick becomes the Gluster file system when it's aggregated with other servers. Gluster does support POSIX compatibility, so you can use ACL, you can use all the same commands and all the same permissions that you've come to be used to with a standard Linux file system, and not be able, and it operates exactly the same. You can use user commodity hardware, so there's nothing special. You don't have to go out and buy SAS drives and really high-speed stuff unless that's what you're trying to accomplish. You can create RAIDs. You can create ZFS RAIDs as your base server builds, and in fact, they do recommend that for when you're actually putting together production workloads. And then you can access that file system either through a Gluster client or using NFS or SMB. So you have a number of options, and there are parallel versions of both SMB and NFS, of course. There is also fault-tolerant ones where if you lose the server that you were connected to, it'll automatically flip over to a different server for both NFS and SMB as well. So, but you can, like I said, you can use any on-disk file system that you want under Linux to create your base file store, as long as it supports extended file attributes. If it doesn't, then you might have a problem. It does support geo-replication, so if you want to have Gluster up and running in two physically diverse sites, so that like if a weather event or maybe a geological event like an earthquake in California, for example, might take out your primary server, the geo-replication has already created the hot store backup for you that you can automatically flip over to, and without a loss of performance or a loss of data. Well, you probably would have some performance differences because the direction of the connections would be going over a little bit longer network. But it also supports quotas, so if you want to hamstring your users so that they can't, take up all the disk space from the other users, you can specify quotas. It also, of course, does replication, and we talked about that a little bit when we were talking about geo-replication, but you can also do replication on-site. It also supports snapshots, and it does have bit rot detection. So as far as a modern file system, yeah, it has those kind of features. Optimization is also possible. It depends on the workload that you're running. So there are different optimizations you can use for configuring. There are variables you can change if you want. And if you have, like large file workloads or small file workloads, there are instructions on the website on how to configure the way that the bricks are configured. And then those will allow you to get higher levels of performance depending upon what your use case is. So I can tell you that most of the time the default one will work pretty well. I don't have huge files. I have video files, and some of those are large, but they're not. I have a few that are 100 gig. But yeah, I mean, it takes it in stride. No big deal. It is also open source, of course, and Red Hat controls both Ceph and GlusterFS development. So I guess the first thing we should do is talk about this upgrade. This was not particularly typical of GlusterFS. I'll say it that way. It isn't typical of GlusterFS. So upgrading GlusterFS in the past has just been simply even going from, whether you're going from a minor version like 8.1 to 8.2 and so on, typically you just do an apt update up to apt upgrade and then restart the systems, and it automatically updates the pools and also the bricks in order for them to support whatever changes that have been made. But I guess in 9.1, there's so many changes that they've made, so many significant changes they've actually done, that just didn't work. It wasn't enough. I couldn't actually bring up any of the Gluster services because of library conflicts after the apt upgrade. So that was the first hurdle I hit. And the second hurdle I hit was after I just did a apt install, tac reinstall on GlusterFS server, and that solved that problem. But then I hadn't upgraded all the servers yet, and it appears to me that, and this is also different, Gluster has always been backwards compatible with older releases, but apparently 9.1 is not. I can't speak for 9.0. I didn't start way back there, but I can tell you that 9.1 is not backwards compatible with Gluster 8.4. So that was the second problem I had, is that even after I got it up, the servers were not communicating. They were not talking to each other. In fact, they were all generating errors. Now, even the pools that had been set up weren't visible. So that was weird. So the way I got around that was the reinstall and the reboot actually took care of that problem as well. But I had to do it on all of the servers in order for the communication to finally link up and all of them to work. It didn't bring up those servers one at a time. They were completely invisible until they were all upgraded. So it appears to me that if you go upgrade to Gluster 9.1, it's a one-way trip unless you want to back everything back down to 8.4. I don't know what kind of hurdles you'll run into doing that. I'm sure there's going to be changes in the config that you just made. So my advice is before you back this up, back up your servers. Yeah, back up your servers. I did that. I had the backup, so I was ready to go backwards if I needed to. But I have not touched my production servers yet, so I have not upgraded them yet. I have started the upgrade on one of the file servers in production. It is done, and it is up and running. But the larger one, I have not done yet. So, but let's take a look, and we'll see what it takes to actually install this. All right, so what I'm going to do is see if I can go up into. Let me just sign on here into the system, and we'll start. The reason I guess I was going to try to get this done on Monday, and it just didn't work out. So yeah, I ran into a couple of problems with Gluster, and it's taken me a little bit of time to figure it out. Well, I guess maybe I better sign in with the right thing. Okay, so right now, as it stands, what I have is I'm running 8.2, and what I want to do is go up to 9.1. So there's been a number of changes in Gluster from 8 to 9, most of them having to do with adding support for like the IO control U-ring. And the reason for that was not necessarily to improve performance, but to allow for new types of I/O and build it into Gluster to be able to handle it. Now they have added some things in order to fill the buffer on reads ahead of time so that it's full, and that will just save time when it goes to do I/O. So that is one of the performance improvements. There's been a lot of other bug fixes and things like that, but what they're really trying to do is get Gluster ready for the future and then improve performance as they go. So I'm not expecting a whole big change here in the performance, but how do we upgrade this, I guess, is the current question. So as you can see, I'm on 8.2. So the easiest way to do this, now I use the PPA in order to get the latest versions of Gluster. Usually if you use the standard libraries from Ubuntu or even Fedora, you'll probably get something that's back a few releases. Now, Ubuntu is pretty good. They're usually about, I think their latest one is 8.1, so they're usually pretty good about keeping up. I wanted to go to Gluster. And then all I need to do is to change this from 8 to 9, which I've already done here. Now, once I've done that, I would then just do an apt update. And that should pull the new repo in, provided I have, there's 9 packages. And that should be That should be 9.1. So, and it is. So, all right. So let's go ahead and do an update upgrade. We'll go ahead and update the Gluster cluster. Now, one thing I noticed, if I were to, this is one of the problems, and hopefully it'll still happen. Yeah, so what's going on here is you'll see a symbol lookup error that says GF update latency. What's going on here is that there are libraries running that are old. And so what I need to do is, I'm going to try this first. Cluster D. I believe that's it. Yep. And then we'll do a start. Let's see if I can get into it now. Nope, still have the same problem. So some of the libraries are not updated, and this is the problem I ran into. This was the first part of the problem. So what I had to do was actually do an install, reinstall on GlusterFS server. That was the only way I could get around it. Now maybe you guys know something better that I don't. I suppose I could try to reboot it, but the libraries are definitely in use that were the 8.2. And so that's not exactly what we want. We want the newer library. So we'll go ahead and get this genned up. I have never had this issue before with Gluster, but that's okay, whatever it is, and then we'll wait for it to come back. This is just a test system. I've already upgraded my production cluster So I just wanted to recreate this for you so that you could see what you might run into. It's not quite up yet. Not quite up yet. Still not up. There we go. Okay, so this time I'm able to actually execute the command. And then the next problem I had was this. Volume info. That works. But I had a problem when I did this. Yeah, it says it's unable. And the problem here is apparently they have changed the particulars on what is sent back and forth on a status command between 8.2 and 9.1. So I need to upgrade the rest of the systems before the actual state information will get sent back and forth between the different bricks, and in order to give me a status on what's going on. So we can actually get back into that now, so that's good. So let's go ahead and go to the next system. And we'll go update our sources list. I'm just going to go ahead and do the reinstall. So let's do a reboot on this one. And then we'll go over to 3, and we'll go ahead while that one's coming up, and we'll go fix this one too. All right, so we'll just wait for that to come back up. I'm sure that 2 is up already. Yeah, okay, so now I just got to wait for it to get to the point where it will start the SSHD server. Now, it doesn't matter which system you're on. You can check status from any one of them. So let's see what we got here. They're all peers, so let's do a pull list, make sure that that's all good. Yeah, it looks good. And then we'll do a volume info like we did before, and that looks good. And let's do a volume status. And that looks good. So you have to have all of them up and running in order for this to work. So now officially I should be on 1.9, and I am. All right, so the next step here will be to run some benchmarks, and I will be back to do that. And then what I'm going to do is compare the 8.2 versus 9.1 and see what we've got. So okay, so let's go to the next step. So I want to do a performance test on Gluster 8.4 and a performance test on 9.1 to see, well, hey, how did this, is this a worthwhile upgrade? Is this going to give me anything different than what I was seeing before? And to be honest, most of the changes involve the support of I/O U-ring. U-ring is the new method for doing asynchronous I/O. It supports threads. U-ring has been making a number of changes, and they've added additional support over the past few releases, and they are continuing to add new things into it that seem to be bringing the performance up. So I wanted to find out, is this really true? The thing is, I wanted to test different kinds of file I/O, like I always do, just to see what happens. It's simulating different workloads, whether it's compilers or database or just straight Linux, and see which one gets the best performance, if there's any difference at all between them. What happens on reads? What happens on writes? How does that impact performance? What if they're mixed, like in a real world? So I'm going to present my results. I'm using IOZone 3 like I always do. I have a GitLab page that has the parameters and so forth that I use to do this. So yeah, my methodology for testing is similar to the FS benchmark. So if you saw that particular video, again, I'll put a link here for you if you're interested in that. All the tests were done on Proxmox, and the reason why I did that was I wanted to get away from the 1 gig network that I have. I don't have a 10 gig. I wanted to find out, though, what would happen if I removed network as the barrier to this benchmark. I probably am going to go back, and once I get some of these servers up and running on 9, I may come back if you guys want. Let me know in the comments if that's what you want to see. Let me know if you want to see it on ARM machines and how I use it here. I'm just hoping that one day we'll have ARM servers with 10 gig networking on them. I know that Jeff Gerling, a guy, has been working on that. He's been playing around with that on his channel, so you might want to check out his. He's been experimenting with file systems on Pis and also network cards. So yeah. So anyway, my server has it's a 6-core, and then there's 64 gig of memory in the system, and I'm using 3 Samsung 1 gig 850 EVO SSDs. I know those are older, but hey, that's what I had. That's what was laying around, so that's what I picked up and used. I'm also going to use Ubuntu 2010 server, and the network, of course, internally in Proxmox simulates a 50 gig network at its peak. I installed everything on one server first, and then I created a clone, and then I created 3 full clones, not clones, but full clones from that, which breaks that dependency on the clone, on the template itself. So, yeah. So anyway, that's what I wanted to do there, and then I enabled IOU ring. Samsung SSD was formatted to the desired file system, and normally on again, I'll put a link to my Gluster install videos, and you can see how I do it. But typically, I use XFS to create my bricks. But like I said, it supports a number of others as well, so you can choose one of those if you wish. But in my case, I only have 1 drive per server. I can't do a RAID, so on the ARM, so it doesn't buy me anything to test that. But I formatted it to XFS, and then I formed my Gluster cluster from the 3 VMs that I created once they were all configured and set up and running. So I wanted to make sure that I forced the cache to be reloaded between tests. There's a total of 13 tests. Again, you can go out to my FS benchmark, and you can see a more in-depth explanation of those. I'm not going to do that today. There's a total of 13 different tests that are performed. Each of those 13 tests are performed a total of 5 times, and you increment the number of users, simultaneous users, each time you do that. And I took that set of tests and I ran them again 3 times. I aggregated the results together, averaged them, and then published my results from that. I'm using IOZone version 3489, and I use the same command line options for IOZone that I always have used. I did not change anything for this. This is what I got. So Gluster 9 is the group of 5 on top, and then this is the read to start out with, and then there is Gluster 8 in the next section. And then reread has Gluster 9 and 8 together, and then initial write has Gluster 9 and 8 together at the bottom. So the blue line is, if you look at the key, is the worker level 1. So it's one user. Then orange is 2 simultaneous users, yellow is 3, green 4, brown 5. So in Gluster 9's case, on the read, it was faster than Gluster 8 for the first user. But it slowed down on the second, and then on the third, fourth, and fifth, it pulled up even again. So adding users to Gluster 9, the performance, as you can see, it just takes it in stride. It's no big deal to it. Reread, but this is capping the drive out. I can't go any faster than the drive is for this. So, or the network. So yeah, that's pretty much what you're seeing here. The reread is similar. Gluster 8 is slower than Gluster 9. Of course, more is better, so the longer lines are better in these tests. So, yeah, and then same thing happens in the workload 2. Gluster 9 drops back a little bit in performance, quite a bit actually, and then it's a little bit faster in the third, and about the same in the fourth. And the fifth, it drops back a little bit more. I don't know why it's doing that. That's kind of weird, but it is what it is, right? I mean, that's what I got. So the write tests, of course, are going to be a lot slower, because when you issue a write, you're actually issuing it to all 3 servers at once. And so you tell all 3 servers to write a copy of the file because of the way I've set up my replicas. I've set them up as 3. So each file writes 3 times, and that's why you're seeing a huge drop in performance here. Again, they're about the same. I mean, on the writes, there isn't any advantage to IOU ring, not here anyway. Because, and the reason for that is simply because Gluster requires the writes to complete before it says the I/O is done, and that is to ensure that the file is managed and keeping its integrity across every place that it's stored. So the stride read was no difference, I would say. I mean, maybe there's slight advantage to 9 up in the fourth user, but I don't really see it. It looks to me like that's pretty much a dead run, a dead heat. The reverse read, yeah, it's about, maybe a slight advantage to Gluster 9 in a single workload, and then it drops back just a little bit on the second, and then it comes right back up again on third, fourth, and fifth. So, I don't really consider that a huge amount of difference. Random read, definitely advantage to Gluster 9 on one workload, and a definite advantage to Gluster 8 on 2 workloads. But then when you get up to 3, 4, and 5, it just evens out and they're all the same. Mixed workload, the random write and P reads are what we're going to look at here, and the random writes, same. It's just what it is. I mean, I have to complete the I/O, and so I'm not really getting any advantage from IOU ring. The P read, slight advantage to Gluster 9 on 1 workload. 2, it's about even at this time. P reads are buffered C code. That's how C does buffered reads. So yeah, typically, I mean, it's up to the programmer what they use, but I mean, typically if you're going to do a buffered read in C, you usually use a P read. If you're just going to do character reads, you usually use an F read or an F write, or that. So Gluster 8 has an advantage on 4 on the P read, about the same on 5. Yeah, it's kind of mixed to me. And then the mixed workload, we're all over the place. First workload looks even, second workload looks even, third workload, Gluster 9 is slower, and then in the fourth it's a little bit faster, just slightly, and then on the fifth workload are about the same. So yeah, that's reading and writing together. So yeah, it's dropped back quite a ways, and obviously it looks like it's about 50-50 on the read-write cycle, so it probably reads and then it writes. I've never taken the code apart to see what it actually does on IO zone, but P-write, again, this is a buffered write. It's a little bit slower than the F-write, of course, because it's pushing more data across the network. F-write, F-write, Gluster 8, definitely faster. That is definitely faster than Gluster 9. And that would be a Linux. That's typical of most of the Linux utilities. Most of them use F-writes and F-reads, unless they have changed things and since I have looked at them. But yeah, for the most part, F-reads and F-writes are typically what you see in Linux utilities. So that's why I include this one. As far as Gluster 8 on the F-read, I'd say Gluster 9, version 9 is doing better until it gets up to the third workload. It drops back, and then it really passes up Gluster 8 on the fourth. And then for some reason, it kind of hangs up and drops back again on the fifth. Again, I don't know what this behavior is about. It might be that there is some, when you get up into the higher workloads, there might be some waiting that's going on, some contention for the processors. I only ran this with 4 cores. So obviously with 5 users, I have a core down, so I'm going to wait for a core to free up in order to run the fifth workload. Each time it's going to have to it's going to have to swap that code segment in and out for the fifth guy. So could be that. Probably ought to go back and give it more memory and more cores and see what happens. Yeah, because I suspect if I add more cores, I'm probably going to need a little bit more memory, but maybe not. So, I guess to conclude this, I would say the read workloads are faster in 9.1 for the lower workloads. I would say that the read workloads and the higher workloads are better with Gluster 8.4, excuse me. But when you get up to 3, 4, and 5, they just become a dead match, dead heat. So all workers write workloads are about the same except for F-write, and F-write workloads 8.4 is faster. So yeah, the higher the workload, in higher workloads, the performance difference is very close. It seems to even up. And there's a few sporadic things that are kind of weird with Gluster 9.1, and that it does drop back on a couple of them. So on some of the higher workloads, and that summarizes pretty much everything. So I've been using Gluster here since about 2015 or so about 6 years now. And I have changed out the servers a couple of times. I started out with XU4 machines from Odroid, which didn't have, they had a traditional USB 3 connection, and then you had to buy a cable and then plug it into a SATA drive. But I have taken those out, and mainly because there just wasn't a lot of memory in them. I think it was a gig of memory was all they had. These that I'm running right now are running on 2 gig of memory, and I don't know how they're going to perform with 9.1, but we'll find out. If you're interested in how that turns out, let me know in the comments below, and maybe I'll do a video on that and come back and tell you about it. So hope you enjoyed this video today. I do want to send out a special shout out to my Patreons. I really appreciate you guys. Without you, I wouldn't be able to do these kinds of things. Go out and buy hardware and then try to put it together and make sure that it's going to work. Yeah, I did get an NVMe file store that runs on Thunderbolt 3. I want to test that with Linux, and that'll probably be my next video, maybe. But we'll see. Anyway, yeah, see what I want to do and what you guys want to do. So if you're interested in that, let me know on that one as well. If you have some other ideas for a video, let me know as well. Hope to see you all again real soon, and bye for now.